Electrolysis. Electrolysis definition. Electrolysis is a process of chemical decomposition of a compound in molten or aqueous state by passing electric current. Compounds that can be electrolyzed. Only compound having free ions, that is ionic compound in molten or in aqueous state, or polar covalent compounds in aqueous state. Why ionic compound need to be in molten or in aqueous state? In solid state, the ions are held tightly by strong electrostatic force of attraction and are not free to move. In molten or in aqueous state, ionic compound undergoes dissociation to form free ions. Why polar covalent compound need to be in aqueous state? Polar covalent compound have molecules only and no ions. In aqueous state, they undergo ionization to form free ions. Ionization and dissociation. Ionization. Formation of positively or negatively charged ions from molecules which are not initially in the ionic state. Dissociation. Separation of ions which are already present in an ionic compound. Ionization. Polar covalent compound like HCl, NH4OH undergo ionization. Dissociation. Electrovalent compounds like NaCl, PbBr2 undergoes dissociation. Metallic conduction and electrolytic conduction. Metallic conduction takes place in solid state. Electrolytic conduction cannot take place at solid state, takes place only in molten or in aqueous state. Metallic conduction takes place by the flow of electrons. Electrolytic conduction takes place by flow of ions. Metallic conduction, no chemical reaction takes place. Electrolytic conduction, chemical decomposition takes place. Electrolytic cell. The given figure explains the formation of an electrolytic cell. Electrolyte. Strong electrolyte, weak electrolyte, non-electrolyte. Strong electrolyte have only ions. Weak electrolyte have molecules and ions, whereas non-electrolyte have only molecules. Strong electrolyte undergoes complete ionization or dissociation. Weak electrolyte undergoes incomplete ionization or dissociation, whereas non-electrolyte undergoes no ionization or dissociation. Strong electrolytes are good conductors, weak electrolytes are bad conductors, non-electrolytes are non-conductors. Strong electrolyte, example, dilute HCl, dilute H2SO4, molten PbBr2. Weak electrolyte, carbonic acid, acetic acid, NH4OH. Non-electrolyte, CCl4, kerosene, sugar solution. Electrolysis is a redox reaction. Oxidation and reduction takes place simultaneously during electrolysis. At the anode, anion lose electrons and are oxidized. At cathode, cations gain electron and are reduced. In the given diagram, anode is the positive electrode, anions move towards the anode, loses electrons and gets oxidized. Hence, anode is the oxidizing electrode. Oxidation of anion takes place at anode. Cathode is the negative electrode. Cations move towards cathode, gains electron and gets reduced. Hence, cathode is the reducing electrode. Reduction of cation takes place at cathode. Anode and cathode together forms electrode, which is metal or graphite rod through which electric current enters or leaves the electrolyte. Electrolysis of molten lead bromide. Cation, lead ion, Pb2+, anion, bromide ion, Br1-. Reaction at cathode, Pb2+ gains 2 electron to form Pb. Reaction at anode, Br2- loses 2 electron to form Br2. Observation at cathode, silvery grey deposit. Observation at anode, reddish brown fumes. Selective discharge of ions. When more than one type of anion or cation are present, only one type of anion or cation will get discharged. 3 factors to decide which ion will get discharged: electrochemical series, nature of electrode, concentration of ions. Electrochemical series. The ions placed lower in the electrochemical series get preference to the ions placed above. The given table represents the electrochemical series. H plus gets discharged in preference to the other cations placed above it. Cu2 plus is discharged in preference to H plus as copper ion is placed lower. OH1 minus get discharged in preference to other anion as it is lowest in the electrochemical series. Electrolysis of acidulated water. Cation H plus, anion Cl minus OH minus. At cathode, hydrogen gains 2 electron to form H2. At anode, OH minus loses 4 electron to form 2 molecules of water and oxygen. OH1 minus is discharged in preference to Cl minus as it is lower in electrochemical series. Electrolysis of copper sulfate solution with copper electrodes. Nature of the electrode plays important role when anode and electrolyte has same metal. Anode becomes active. Ions present Cu2 plus, H plus, SO4 minus, OH1 minus. At cathode, Cu2 plus gains 2 electron to form Cu. At anode, Cu loses 2 electron to form Cu2 plus. Cathode becomes thicker, anode becomes thinner, blue color of electrolyte remains the same. Why the blue color of the electrolyte remains the same? At cathode, Cu2 plus gains 2 electron to form Cu. At anode, Cu loses 2 electron to form Cu2 plus. As one copper ion is discharged at cathode, one copper ion is formed at the anode. Concentration of the copper ions remains the same. Applications of electrolysis. Applications: electroplating, electrorefining, extraction of metals. Electroplating: the electrolytic process of deposition of a superior metal like Ag, Ni, Cr, Au on the surface of base metal or article. Why electroplating is done? Prevents corrosion or rusting of base metal, makes the article attractive and gives it an expensive appearance. The given setup explains electroplating with silver. Electrolyte: sodium silver cyanide solution, NaAgCN2 solution. Silver nitrate solution cannot be used. Silver nitrate decomposes in the presence of light and results in uneven deposition of silver. Cathode: the article to be plated. Anode: silver block. Electrode reactions. Cathode: Ag plus gains 1 electron and forms Ag. Anode: Ag loses 1 electron and forms Ag1 plus. Electroplating with nickel. Electrolyte: nickel sulfate solution. Cathode: object to be electroplated. Anode: nickel bar. Reaction at cathode: Ni2 plus gains 2 electron and forms nickel. Reaction at anode: Ni loses 2 electron and form Ni2 plus. Electrorefining of copper: process of purifying impure copper by passing electric current. The given setup explains electrorefining of copper. Electrolyte used: CuSO4 solution. Cathode: pure copper. Anode: impure copper. At cathode, Cu2 plus gains 2 electron and forms Cu. At anode, Cu loses 2 electron and forms Cu2 plus. Assignment: to carry out the so-called electrolysis of water, sulfuric acid is added to water. How does the addition of sulfuric acid produce a conducting solution? Addition of sulfuric acid causes the ionization of water. The presence of H plus ion, OH minus ion and SO4 minus ion in the solution makes the solution conducting solution. Why electrolysis of water is carried as catalytic reaction? H2SO4 added to carry out electrolysis remains unchanged after the process. It is added to make water a conducting solution. Explain how electrolysis is an example of redox reaction. During electrolysis, an ion loses the electrons at anode and gets oxidized, whereas cation gains electron at cathode and gets reduced. What ions must be present in a solution used for electroplating with a particular metal M? Ions of metal M. Electrons are getting added to an element Y. Which electrode will Y migrate to during electrolysis? Anode.